Okay, this is from the 2019 paper 1, question 8 on the topic of your differentiation, right? So they tell you the equation of the curve is as such, find the dy dx as well as the d square y over dx square, right? So we're just supposed to differentiate this, right? The first one, we can just get it to be differentiate x, we just get 1, right? The second one, we will need to use our quotient rule. So let's use our quotient rule for this. I'm going to start at the denominator. My denominator is going to square, right? And I'm just going to leave my denominator as it is. Differentiate my numerator, I get it to be 2. For quotient rule, in between is minus, so minus. And I'm going to differentiate my denominator, which I get it to be 1, right? Because differentiate x minus 2, I just get 1. And I'm going to leave my numerator. Okay, then we're just going to simplify this. The 1, just leave it outside, perfectly fine. The top, we're going to get it to be 2x minus 4, right? Minus 2x minus 5, right? Because you open up the bracket, the minus sign goes in, right? Over x minus 2 square. Simplify this further, I'm just going to get it to be 1 minus 9 over x minus 2 square. Okay, so this is your dy dx. After you get your dy dx, we need to find the d square y over dx square. So just differentiate this one more time. Okay, 1 just disappears, right? If need be, you can write this out again, right? This is just the same as negative 9 x minus 2 to the power of negative 2, right? So here you need to use your chain rule, right? Bring down the power, negative 9 times negative 2, power minus 1, which you get minus 2 minus 1 becomes minus 3. Differentiate the inside, you just differentiate x minus 2, you just get 1, right? Just simplify this, you'll get it to be minus 9 times minus 2, you get 18. Right, bring this down to the denominator. So you just get it to be 18 x minus 2 cubed. Right, so this is your d square y over dx squared. Okay, both of these are your final answers for part 1. Okay. Part 2, they tell you find the x coordinate for the stationary points of the curve. So for stationary point, all you need to do is to equate your dy over dx to be equals to 0. Right, so this is when your gradient is equals to 0 for any curve, right? So we equate our dy dx, which is just 1 minus 9 over x minus 2 square equals to 0. Simplify this, we just get it to be 9 over x minus 2 square equals to 1. Cross multiply, we get x minus 2 square is equals to 9. Here you need to expand it, or if you want, you can also square root it straight away. I would actually just square root it straight away, and I'm going to get my plus minus. So x minus 2 is equals to plus minus 3, because root 9 we square root, you get negative 3 or positive 3. So here I can conclude that x minus 2 equals to 3, or my x minus 2 equals to negative 3. Simplify here further, you just get it to be x equals to 5, or that of x equals to minus 1. These are your final answers for part 2, stationary point. Okay, and for part 3, they tell you determine the nature of each stationary point. Well, we have the d square y over dx square. So all we need to do is just to sub in, right? So sub x equals to 5 and sub x equals to negative 1 into my d square y over dx square, right? Which is just 18 over x minus 2 cubed. So it's going to be equals to 18 over 5 minus 2 cubed. And for this, it's just going to be d square y over dx square is equals to 18 over negative 1 minus 2 cubed. Simplify this further, well, we're going to get it to be equals to 2 over 3, right? And the other one is just going to get us minus 2 cubed, right? We're just going to get negative 2 over 3. Right, and since this is more than 0, we can conclude that at x equals to 5, this is a minimum point. And for this, since it's less than 0, we can conclude that at x equals to 1, this is a maximum point. Okay, so yeah, this is how you do question 8 of this differentiation question. Very simple, very straightforward.